Welcome to Foundation Home Learning. This is a foundation unit appropriate for children learning from home during this extended school closure. It is designed to provide learning opportunities within the national curriculum within science, history, geography and art. This is lesson number 5 in the series. Please listen along, pause the video when necessary, and listen out for the task appropriate for your age and ability. To be prepared for today's lesson, make sure you have something to write with and your home learning book. Follow along with the video and be sure to pause when you have been given a task to complete. You will know when to pause the video when you see the symbol in the bottom corner of the screen. Today's learning objective is to understand how explorers navigated the oceans.
The early ocean voyages were probably big mistakes. A vessel could be thrown off course by a sudden storm or error by the helmsman. So, how did the early sailors navigate the oceans? Long before the magnetic compass reached Europe, the Vikings were sailing across oceans to both the east and west, discovering new lands in the west such as Iceland and Greenland, and even discovering America, nearly 500 years before Christopher Columbus. These brave Vikings were creative in compensating for their lack of technology. Floki Vilgerdarson, a great Viking explorer credited with the discovery of Iceland, carried aboard a cage of ravens. When he thought land should be near, he would release one of the birds. If it circled the boat without purpose, land was not near. But if it took off in a certain direction, the boat followed, knowing the bird was headed toward land. The early Pacific Polynesians were the first to use the motion of the stars, weather, the position of certain wildlife species, or the size of waves to find the path from one island to another. Using the motion of stars? Imagine one night you call a friend who's a few thousand miles away and ask them to name the star which is directly over their head. You could then find that star in the night sky, and the point on the horizon directly below that star would be their exact direction from you at that moment. Unfortunately, a few minutes later that star would have moved, and so you'd need a new one. With this method, it would take a lot of phone calls for every new star. Fortunately, there is one star in the night sky that does not appear to move. It's called Polaris, the North Star. The easiest method for finding the North Star is by finding the Plough, an easy-to-identify group of 7 stars. It is known as the Big Dipper to the Americans and the Saucepan to many others. The Plough rotates anti-clockwise about the North Star, so it will sometimes appear on its side or even upside down. However, its relationship to the North Star never changes, and it will always dependably point the way to it. The first useful invention to help was the magnetic compass. With that, you could hold a steady direction as you sailed. And with something called a dead reckoning, sailors estimated their ship's speed by noting the time it took for a wood chip, a bubble, or a piece of seaweed to pass along the length of their vessel. But since the time was measured with a sand glass, these early calculations were often way off. To determine a position on Earth's surface, it is necessary and sufficient to know the latitude, longitude, and altitude. Altitude considerations can, of course, be ignored for vessels operating at sea level. If you have a compass, know the date, and have a set of prepared navigation tables showing how high the sun should be at local noon, then you can determine your latitude easily. But to calculate your longitude, you need, oddly enough, a very accurate clock, which is calibrated to Greenwich Mean Time, or GMT. Here's why. We know that Earth revolves about its axis once every 24 hours. In other words, the Sun completes its apparent revolution of 360 degrees in 24 hours. So in 1 hour, the Sun appears to move 15 degrees. In 4 minutes, it appears to move 1 degree. In 1 minute, it appears to move 15 arc minutes. In 4 seconds, it appears to move 1 arc minute, and so on. If you're sailing and it's 1800 hours GMT and the local time is 800 hours, then you get a time difference of minus 10 hours. Minus 10 hours is minus 150 degrees. Therefore, you are 10 hours behind GMT, which means your longitude is 150 degrees west. In 1714, the British government offered a prize to anyone who could perfect and demonstrate a clock that would be accurate enough over long voyages to give the desired precision in locating a ship. This type of clock was called a chronometer. But the problem was that all the clocks of the time were mechanical. They were upset by changes in temperature, humidity, vibration, corrosion, etc. In 1775, Captain Cook returned from a 3-year voyage, having used one of the chronometers submitted by Larkham Kendall, which was a copy of the H4 clock made by John Harrison. Upon comparing it to local reference clocks, it was found to have been accurate to within 8 seconds per day. Nowadays, of course, navigating is much simpler. All large ships today rely on global positioning system. Marine GPS receivers don't show streets, they give longitude and latitude, and typically also show maps of any nearby coastlines, harbors, lighthouses, etc. Many also display the approximate depth of the water as well. Many marine GPS units now have a man overboard button. If someone falls overboard, the captain or other crew member presses that button. The GPS unit then marks that spot in the ocean and typically displays a directional arrow pointing to it, along with a distance reading to that spot. That lets the captain turn the ship around and return to the spot where the person fell into the water. I suspect most ships even now carry a sextant, a handheld instrument used to measure angles between the sun and moon and horizon, as a backup to their GPS systems. With that and an accurate wristwatch and navigation tables, a competent navigator can still find where he is on the ocean, even if the modern GPS unit fails. So when you're sailing, you might not save time, but time just might save you.
Time for your first quick task. In your home learning book, can you name the different ways in which explorers managed to travel the ocean to discover the new lands without getting lost? Here are the navigation tools that we found. Birds, the stars and the sun, weather, wildlife, the size of waves, magnetic compass, latitude and longitude, a chronometer, global positioning satellites, and a sextant. Invisible lines of latitude and longitude form a grid over the Earth. These lines help to create a coordinate to locate a place accurately. Using these coordinates, you can find anywhere on Earth. Modern navigators use GPS to map where they are going. You can now use GPS to become an explorer yourself. Google Maps and Google Earth use GPS to allow you to navigate the entire planet. GPS still uses latitude and longitude, but the satellites find this for us much more accurately. Time for your next quick task. By typing the exact coordinates into Google Earth or Google Maps, you can find the exact points on Earth. Using either Google Earth or Google Maps, can you find where these places are below? Remember to type the exact coordinates into the search bar. Early years, here's your main task. With your home teacher, name as many countries as you can, and in your home learning book, use your letter sounds to sound out and write them. Here's a little challenge. Can you research, draw and colour the flag of the UK? Year 1 and 2, here's your main task. On the next slide is a world map. With your home teacher, can you identify the countries that have been labelled? Here's a little challenge. Can you also draw a picture of each country's national flag and tell me some interesting facts about each country. Here is the world map. Remember to note down each country in your home learning book. Year 3 and 4, here's your main task. Imagine you are an explorer who is going to travel around the world. Explain in detail how you will travel around the world, what you are looking for, what you will use to navigate the oceans, who will you bring with you and why. Plan your route on a map of the world and identify the countries you will travel by. And can you use longitude and latitude coordinates to plan your route? And finally, Year 5 and 6, here's your main task. Imagine you're an explorer who's going to travel around the world. Explain in detail how you will travel around the world, what you are looking for, what you will use to navigate the oceans, who you will bring with you and why, what are the dangers of travelling by sea, and give exact longitude and latitude coordinates to plan your route using Google Earth or Google Maps, while identifying the countries you would travel by. So how have you done? Time to share your work with the class. Read your work to your home teacher, but don't forget to check for spelling and punctuation mistakes and that you've completed all the success criteria for today's task. Well done everybody. That's the end of lesson 5. Be sure to join us again in the next lesson.